let's take some examples on center of mass. So we have three masses, and these masses are positioned. Let's say this is 2 kilogram mass, and this is positioned at 5, 5. This guy is positioned at, let's say this is 3 kilograms, and this is positioned at minus 5, 5. And this guy, which is 4 kilograms, is positioned at minus 5, minus 5. So I have given the Cartesian system. So what is center of mass of this system? Okay, so we have the standard definition, which is sum over mi ri. We decided to choose r instead of x in the last lecture, divided by sum over mi. What does that give? This gives 2 multiplied by 5, 5 plus 3 multiplied by minus 5, 5 plus 4 multiplied by minus 5, minus 5 divided by 2 plus 3 plus 4, and this is nothing but 15 and 20 gives 35, minus 10 is minus 25, comma 10, and again this, well, 15, 5 to the 10, 25 minus 20 is 5 divided by 9. So this is r, or you can say it's the same as minus 25 divided by 9 divided by 9. Okay, let's take one more example, which is for continuous system. So let's say we have meters, well, not a meter stick, let's say we have a stick. Well, let's take a meter stick. This is 1 meter and it weighs 10 kilograms. Well, it's not really, this thing is not really required, but let's assume it weighs 10 kilograms. And we have to find what is r for the system. We can define this as the x-axis and this as the y-axis. For the sake of convenience, let's say the thickness is 10 centimeters or 1 centimeter. It doesn't really make difference, but that's a standard problem. Okay, so this is the setup, this is the problem, and r is, we know, is going to be rho r dA divided by rho dA. Now what is rho? Well, rho is the area density. Rho, as we decided, was mass over area, which is area of this meter stick, and that is 0.01, and that gives us 1000 kilogram. What are the units? Over meter square. So that is the density. Okay, now we have to integrate this whole thing over this whole meter stick. So what should we do? We can choose a small area element somewhere here. Let's say it has a width of dx because it's in the x direction. All the meter stick is in the x direction, and let's say it has a width of small dx. So you can write dA equals 0.01 dx. That is the area, because that's a small rectangle out there. So r, or this term, will be 1000, and also let's assume this dx is the length as a distance x from the origin. So that gives us x multiplied by 0.01 multiplied by dx divided by and we are trying to calculate r here, divided by rho dA, which is nothing but the mass of the whole thing, which we already know is 10. So this gives us, you see, 10,000 and 0.01, they get cancelled, and we are left with x dx 0 to 1, and if you do a small calculation, this will turn out to be half meters. This is very simple integration. So we know, which we already knew from the very beginning, the center of mass of this meter stick lies at half meter, somewhere here, which makes sense. In the next lecture, we'll talk about a more difficult example.